Welcome, curious minds and sleepy thinkers. You've found a soft place to land where the questions are vast and the pace is slow enough not to jolt you out of your pillow cocoon. Let the day's worries drift away like tiny motes of dust in the sun's gentle light. Tonight we're going to tiptoe into one of the most mysterious questions ever asked. Where do we fit into this impossibly large story? We'll drift through ideas that stretch the imagination not as a race through equations, but more like floating through a galaxy of ideas with a warm cup of tea beside you. So settle in, let your mind become quiet, and allow yourself to simply wonder. Let's begin by imagining the universe itself. Not as a concept in a book, but as a feeling. Feel the immense quiet of it, the scale that humbles every thought, the deep velvet darkness punctuated by the faint, shimmering light of billions upon billions of galaxies. Each one a swirling city of stars, and each city a kingdom of its own with countless suns and planets, dancing in a silent, endless ballet. Our own galaxy, the Milky Way, is but one of these celestial cities. Picture it from a distance, a graceful spiral of light, our sun, a single, unremarkable resident in one of its tranquil outer neighborhoods. And on a small blue planet, circling that star life has taken hold. We've only just begun to uncover its mysteries. Our story. The story of life began as a flicker in the vast darkness, and it has blossomed into something that can ask questions, that can listen to this very story. We can look up and see the same stars that our earliest ancestors saw, and we can use our minds to imagine a time before those stars even existed. Our journey is a journey of understanding, a quest that takes us from the quiet ocean floor to the very edge of the cosmos. We are at once both the stewards of a small fragile world and the explorers of an endless expanse, a duality that lies at the heart of our very existence. So let's allow our minds to travel outward. Past the moon, past the sun, past the familiar planets of our home system. Feel the deep, profound silence of the void between the stars. It is not an empty silence, but a stillness teeming with potential, with the ghosts of ancient light and the promise of future creation. This is the stage upon which our story unfolds. We will trace the threads of this cosmic tapestry from the fierce, blinding birth of the universe to the quiet whisper of a single thought. The sheer scale of the universe is a concept that can almost be overwhelming to the mind, and so we must approach it gently, one small idea at a time. It is not a place that can be fully grasped, but a feeling that can be experienced. Imagine that you are a tiny seed in a vast field. This field is our universe, and it is so large that your seed and all the seeds around you could not even begin to fill it. Now imagine that you look up and see other fields and other fields, each one a universe of its own, stretching out into an endless vista. This feeling, this sense of being part of something so impossibly large, is what brings us to the edge of wonder. The mystery of the cosmos is not just its size, but its very nature. How does a universe come to be? How does matter? How do stars, how do galaxies all emerge from a singular hot point? These are the questions that have whispered in the ears of thinkers and scientists for centuries. And as we've learned more, the questions have only grown more beautiful, more complex. We've gone from simply wondering about the stars to wondering about the very fabric of space and time. We've gone from looking at the moon to wondering if life could exist on its distant shores. The mystery is a constant companion on our journey, a gentle reminder that we are only at the beginning of our story. We are in a very real way a part of this story. The stardust that makes up our bodies, the iron in our blood, the calcium in our bones, all of it was forged in the fiery heart of a star that lived and died billions of years ago. Our existence is a continuation of a cosmic cycle, a profound inheritance from the past. And as we explore the universe, as we ask these questions, we are not just observing something separate from ourselves. We are observing our own origins. We are looking into a cosmic mirror, and in its endless reflections, we see our own beginnings. This is the core of our journey to understand where we come from, so that we can better understand where we are. So let's begin with the biggest question of all. Let's start at the very beginning, with the most prominent and widely accepted theory of cosmic origin, the Big Bang. But first, let's take a moment to simply breathe and absorb the vastness of what we're about to imagine. The idea is so grand, so overwhelming, that it requires a quiet mind. It asks us to set aside our everyday notions of time and space, to imagine a reality that is so dense, so hot, so utterly unlike our own, that our language almost fails to describe it. We stand at the precipice of a new story. The story of a universe that began as an infinitesimal point, a point so small, so dense, and so hot that it defies our comprehension. But don't worry, we won't stay there for long. We'll watch as this universe expands, as it cools, and as it begins to take shape. We'll see the formation of the simplest elements, the building blocks from which all matter in the cosmos is made, and we'll watch as these elements, these first whispers of matter, come together under the gentle pull of gravity to form the first stars and galaxies. This is not a story of an instant, but of a process that unfolded over billions of years. It is a story of slow, deliberate creation of a universe that is constantly expanding, constantly evolving, and constantly surprising us with new wonders. It is a story that reminds us that even from the most chaotic beginnings, order and even life can emerge. This gentle exploration of our place in the cosmos is a way to find a sense of peace in the vastness. It's a way to feel connected to the stars and the galaxies, to feel that our own existence is part of something larger, something more profound than we can ever fully grasp. The quiet hum of the universe is a lullaby, a story that reminds us that we are not alone. We are simply a small but vital part of a grand and beautiful mystery. We've explored the initial idea of the cosmos's immense scale and our place within it. Now let's tiptoe a little closer to the ultimate origin story. The prevailing theory, as you may know, is the Big Bang. But the name itself can be misleading, creating a picture in our minds of a loud, violent explosion like a firecracker going off in a dark room. The reality, as we will gently discover, is far more subtle and profound. It was not a bang in space, but rather the beginning of space and time themselves. Imagine, if you can, a time when the very concepts of before and where did not apply. This is the singularity and almost mythical point of infinite density and temperature. It is a concept so abstract, so beyond our human experience, that our minds have no framework to truly understand it. It is where our current physics breaks down, where the equations become silent, leaving us standing at the edge of a great, beautiful mystery. And perhaps that's not a flaw, but an invitation to simply wonder. What could have led to such a moment? What does it even mean for something to exist outside of time? We can't answer these questions with certainty, but we can hold them in our minds like polished stones, turning them over and over, marveling at their smooth, unyielding silence. From this incomprehensible point, about 13.8 billion years ago, the universe began to expand. This was not an explosion that sent matter flying outward into a pre-existing vacuum. Instead, imagine a balloon with no air inside, just a tiny invisible point at its center. Now imagine that balloon being inflated. As it fills with air, the surface itself stretches, growing larger and larger. Any points you draw on that surface will move away from each other, not because they are crawling across the rubber, but because the rubber itself is expanding. That, in a very simple and gentle sense, is our universe. Space itself began to stretch, and as it did, it carried everything with it. The galaxies that we see today, all moving away from us, are not doing so because they were violently flung away. They are simply riding the crest of this great ongoing cosmic wave of expansion. In the first moments, the universe was an unimaginably hot and dense soup. Particles and energy were indistinguishable, all compressed into a seething, chaotic dance. But as the universe stretched and cooled, the fundamental forces of nature began to emerge one by one, like separate notes in a symphony. The strong nuclear force, the weak nuclear force, electromagnetism, and gravity. These are the forces that now govern our world, from the orbits of planets to the bonds in our own bodies. They were all born in those first frantic moments, shaping the universe into the form we see today. This early period was also defined by a concept known as cosmic inflation. Imagine the balloon analogy again. After its first tiny puff of air, it didn't just slowly grow. Instead, it experienced a brief explosive and unimaginably rapid growth spurt. This inflationary phase would have smoothed out any wrinkles or irregularities in the early universe, much like a quick snap of a sheet makes it perfectly flat and even. It's a hypothesis that helps to explain why the universe on a very large scale looks so uniform today. And while much remains uncertain about what drove this rapid expansion, it provides a powerful glimpse into the conditions that prevailed at the universe's birth. So, where does this leave us? We've considered the very beginning, the incomprehensible singularity, and the great stretching expansion that followed. We've seen how the universe in its infancy was a chaotic but beautiful ballet of forces and particles, and we've seen how a brief dramatic period of inflation may have smoothed out the wrinkles, preparing the stage for the formation of stars and galaxies. But this is only one part of the story. The Big Bang is not just a theory of origin, but also a theory of evolution. It tells us how the universe has changed and grown over billions of years. And in the next part of our gentle journey, we'll look at the silent, unwavering evidence for this story. We'll explore the cosmic background radiation, the ancient light that still whispers to us from the dawn of time. We'll look at the red shift of distant galaxies, and we'll discover how the universe's first elements are a silent, unwavering confirmation of its explosive birth. For now, let's simply rest in this idea that from a single point, a universe of billions of galaxies has blossomed. That from a hot, dense soup, all of the complexity and beauty we see today has emerged. It's a thought that is both humbling and deeply inspiring. It reminds us that we are not separate from the cosmos, but an intimate part of its grand unfolding story. We are a part of a great cosmic epic, a story that is still being written. And that in itself is a profound comfort. So let yourself drift off with that thought, a thought that stretches from the singularity to the quiet comfort of your own room. The story is only just beginning. Let's continue our quiet journey, gently turning our attention from the first moments of the universe to the soft whispers it left behind. If the Big Bang was the dramatic opening chord of a cosmic symphony, then the echoes of that chord are still rippling through the universe today, a faint, beautiful hum that we can actually hear. This is the cosmic microwave background radiation, a mouthful of a name for what is essentially the faded photograph of the baby universe. Imagine for a moment that you were standing in a great hall where a single brilliant flash of light occurred. You wouldn't see the light itself, for it would be too fast, too overwhelming. But a moment later, when the light has reflected and scattered off every surface, you would be left with a soft ambient glow, a gentle afterglow that fills the entire room. The cosmic microwave background radiation, or CMB, is that glow. It's the very first light that was able to travel freely through the universe about 380,000 years after the Big Bang. Before that, the universe was too hot and dense, a thick fog of charged particles where light couldn't escape. But as it cooled, the electrons and protons were finally able to come together to form the first atoms, and suddenly, the fog lifted. The universe became transparent, and that initial brilliant flash of light was set free. Over billions of years as the universe has expanded, that light has stretched and cooled. What was once a brilliant flash of visible light has shifted down the electromagnetic spectrum, becoming the faint glow of microwaves that we can detect today. It's a universal hum, a soft, constant buzz that comes to us from every direction, a gentle whisper from the past that tells us without a doubt that the universe was once an incredibly hot, dense place. We can't see it with our eyes, but we can listen to it with our instruments. And in doing so, we are listening to the echo of creation itself. The story of how we discovered this hum is a gentle one too. In the 1960s, two scientists, Arno Penzias and Robert Wilson, were working with a large radio antenna trying to detect signals from space. No matter where they pointed their antenna, no matter how much they cleaned it, even removing a pigeon nest they suspected was the cause of the noise, they kept hearing a faint, constant hiss. It was coming from everywhere, a persistent, unchanging buzz. They had stumbled upon the cosmic microwave background radiation, a relic from the universe's past that confirmed the Big Bang theory in a spectacular and unexpected way. They were, in a sense, the first to hear the universe's quiet lullaby. But the CMB isn't perfectly uniform. It's filled with tiny, beautiful ripples, like the surface of a perfectly still pond after a distant pebble has dropped. These subtle temperature variations, just a few hundred thousandths of a degree, are incredibly important. They represent the tiny fluctuations in density that existed in the early universe, the seeds from which all future structures, all the galaxies, all the stars, all the planets would eventually grow. Imagine a perfectly smooth, velvety curtain. The CMB is like that curtain, but with the faintest, most delicate folds and creases. And those creases, those slight imperfections, were the starting points for everything we see around us today. So the cosmic microwave background radiation is more than just an echo. It's a map. It's a blueprint. It's a family portrait of the universe when it was just a tiny infant, a portrait that shows us the seeds of its future self. It reveals a universe that was once homogeneous and simple, but also contained the potential for immense complexity. It is a powerful piece of evidence, a profound connection to our past that helps us understand how we got here. The CMB is one piece of the puzzle, but there are other equally gentle clues that confirm the Big Bang story. Another, just as profound, comes from observing the movement of galaxies. Imagine again our balloon with dots drawn on its surface. As the balloon expands, every dot sees every other dot moving away from it. The dots are not crawling across the rubber. The rubber itself is stretching. And the farther apart the dots are, the faster they appear to be moving away from each other. This is exactly what we observe when we look at the universe through our telescopes. When an astronomer named Edwin Hubble looked at distant galaxies in the early 20th century, he discovered that they were all moving away from us. And not only that, but the farther away a galaxy was, the faster its light was redshifted, a subtle change in the light's color that indicates it is being stretched as the galaxy moves away from us. This stretching of light is a direct consequence of the stretching of space itself, and it is a powerful confirmation of the ongoing expansion of the universe. This phenomenon, known as Hubble's law, is like a reverse detective story. If everything is moving away from everything else, then if you rewind the clock, everything must have been much closer together in the past. If you keep rewinding, all the galaxies collapse back into a single infinitesimally small point. Hubble's observations were the first to provide direct observational evidence for a universe that was not static and eternal, but was born in a single moment and has been expanding ever since. And what about the building blocks of this universe? Our third piece of evidence for the Big Bang comes from the very stuff that makes up the cosmos. According to the theory, in the first few minutes after the bang, the universe was hot and dense enough for a process called nucleosynthesis to occur. This is a very elegant name for the process of creating the first elements. In a cosmic flash, protons and neutrons were fusing together, creating the first hydrogen, helium, and a tiny bit of lithium. It was too hot for anything heavier to form, so the universe was left with this perfect simple blend, about 75% hydrogen, 25% helium, and trace amounts of lithium. And when we look at the universe today, that's exactly what we see. The most abundant elements are hydrogen and helium, in exactly the proportions that the Big Bang theory predicts. It's like finding a cosmic fingerprint, an unmistakable signature of a universe that was once a hot, dense crucible of creation. This abundance of light elements is a powerful silent confirmation of the universe's early moments, a testament to a time when everything was simple and new. So let's bring these three gentle clues together. We have the cosmic microwave background radiation, the faint echo of the first light that fills the universe. We have the expanding universe, the beautiful ongoing stretching of space that we can see in the redshift of distant galaxies. And we have the cosmic fingerprint, the perfect simple blend of hydrogen and helium that was forged in the universe's first few minutes. Together, these pieces of evidence form a robust and beautiful case for the Big Bang Theory, a story that tells us not only how the universe began, but how it continues to evolve. The universe is not a static place. It is a dynamic, evolving story, a story that is still being written. And as we continue to listen to the echoes of the past and observe the movements of the present, we are slowly, gently, and with great humility, learning to read that story. We are learning how the quiet hum of a baby universe became the chorus of a trillion stars, how a simple blend of elements became the foundation for all the complexity we see today, and how a single moment of expansion became the endless canvas upon which our own story is painted. And in this journey, we are reminded that we are not separate from this grand cosmic epic, but an intimate, vital part of it. Let's drift into a quieter, more mysterious corner of the cosmos, a place where the universe holds on to its secrets with a gentle but firm grip. We've spoken of the matter we can see: the stars, the galaxies, the planets, and even ourselves. But what if all of that, everything we've ever observed, every piece of light we've ever collected, is just a small shimmering detail in a much larger, darker picture? Tonight, we'll explore the two most enigmatic components of our universe: dark matter and dark energy. They are the unseen forces that sculpt our reality, a testament to how much more there is to learn. Imagine a great cosmic dance. We see the dancers, the galaxies, the stars twirling and spinning, a brilliant performance in the dark theater of space. But when we measure the speed of their dance, we find something strange. They are spinning far too fast. If they were to spin at this speed, the centrifugal force would fling them apart, like a child spinning too fast on a merry-go-round. Yet, they hold together. It's as if there is an invisible dance partner, a force of immense gravity that we cannot see holding them in a gentle, firm embrace. That unseen partner is dark matter. Dark matter is a form of matter that doesn't emit, absorb, or reflect light. It is completely invisible to our telescopes. We can't see it, but we can feel its presence through its gravitational effects. It acts as the scaffolding of the cosmos, the silent, invisible framework upon which galaxies and galaxy clusters are built. Without it, the universe as we know it would not exist. The galaxies would have torn themselves apart long ago, and the great cosmic structures would never have had the chance to form. We believe it makes up a staggering 27% of the total mass and energy of the universe, yet its nature remains one of the most profound mysteries in science. We can search for it, of course. We build elaborate detectors deep underground, hoping to catch a stray particle of dark matter as it passes through the Earth. We search for subtle clues in the way light bends around galaxies, a phenomenon known as gravitational lensing, which shows us the presence of this hidden mass. But for now, its true identity is a mystery. It is a quiet reminder that what we see is not all there is, that the universe is far more subtle and complex than our eyes can perceive. And in that uncertainty, there is a kind of beautiful poetry. It's an invitation to simply wonder about the nature of reality itself. What if there are countless things around us that we simply cannot perceive, quiet forces that shape our world in ways we can only begin to guess? Now let's turn our attention to an even more baffling mystery: dark energy. We've spoken of the expanding universe, the great stretching of space that began with the Big Bang. For a long time, we assumed that this expansion would slow down over time as the mutual gravitational pull of all the matter in the universe worked to bring everything back together. It was like throwing a ball into the air, expecting it to eventually slow down, and fall back to Earth. But in the late 1990s, we made a discovery that completely upended this gentle assumption. We found that the expansion of the universe is not slowing down. It is accelerating. Imagine that same ball you threw into the air. Instead of slowing down, it starts to speed up, flying faster and faster away from the Earth. It's as if there is an invisible, quiet, but relentless force pushing it. That force is dark energy. It is a powerful, mysterious component that makes up about 68% of the universe's total energy content, and it acts in opposition to gravity, pushing galaxies apart, stretching space itself. We know even less about dark energy than we do about dark matter. We don't know what it is, where it comes from, or why it exists. It is a profound challenge to our understanding of physics, and it raises some of the most fundamental questions about the ultimate fate of the universe. If dark energy continues to dominate, what does that mean for the future? Will the universe expand forever, becoming a cold, diffuse, and lonely place where galaxies drift so far apart that the light from one can never reach another? Or will it change, leading to a different destiny? This quiet acceleration is a silent but powerful mystery, a reminder that the universe's story is still unfolding in ways we can only begin to guess. Dark matter and dark energy together are a humbling thought. They remind us that the vast majority of our universe is hidden from us, that what we see and touch is a small, beautiful island in a great unseen ocean. We are made of the ordinary matter that makes up only about 5% of the cosmos, and yet we are surrounded by these invisible forces that shape our reality. It's a realization that can lead to a sense of profound wonder, a feeling that we are living in a universe that is far more mysterious and magical than we ever could have imagined. The mystery deepens when we turn our attention to the cosmic phenomena that exist at the extremes of space and time. Let's drift into the idea of a black hole. The name itself conjures up an image of a great cosmic vacuum cleaner sucking everything into its maw. But the reality is far more elegant and beautiful. A black hole is not an empty space, but rather a place where gravity is so strong, so intense, that nothing, not even light itself, can escape. Imagine a perfectly still pond with a single massive stone dropped into its center. The stone creates a deep well, a distortion in the surface of the water. Now imagine that stone becoming heavier and heavier, its gravity pulling the water around it into a steeper and steeper slope. At a certain point, the slope becomes so steep that a boat, no matter how fast it travels, can no longer escape its pull. It is drawn inexorably toward the center. A black hole is that great bottomless well, a place where the fabric of space-time itself has been stretched and warped into an abyss. The formation of a black hole is a spectacular, violent event. It typically begins with a massive star, one far larger than our own sun. After billions of years of burning, the star runs out of fuel. The delicate balance between the outward pressure of its nuclear fusion and the inward pull of its own gravity is broken. The star's core collapses under its own immense weight, while its outer layers are violently expelled in a brilliant explosion known as a supernova. This is one of the most powerful events in the universe, a brief, spectacular flash of light that can outshine an entire galaxy. What is left behind is a core so dense that it collapses into a point of infinite density. This is the black hole, a silent, powerful monument to the death of a star. There are many types of black holes, from stellar black holes formed from individual stars to the supermassive black holes that lurk at the center of every galaxy, including our own. These supermassive black holes can be millions or even billions of times the mass of our sun, and their presence is crucial to the life and evolution of their host galaxies, influencing the orbits of stars and the formation of new solar systems. Black holes are a testament to the power of gravity, a force that, in its most extreme form, can tear the very fabric of reality. They are a mystery that we are only just beginning to unravel. And as we've learned to observe the universe in new ways, we've found a new way to listen to their story. This brings us to another profound discovery: gravitational waves. More than a century ago, Albert Einstein, in his theory of general relativity, predicted that massive accelerating objects would create ripples in the very fabric of space-time, much like a stone dropped in a pond creates ripples in the water. For a long time, these ripples, these gravitational waves, were purely theoretical. We had no way to detect them. But in 2015, we finally built instruments sensitive enough to hear them. Imagine for a moment that you are a silent observer of the cosmos. You've been watching for billions of years, but you've only been able to see with your eyes. You've only been able to perceive the light from stars and galaxies. Now imagine that you are given a new sense, the ability to hear. In this new sense, you hear a sound, a gentle thrum in the darkness, a quiet, profound vibration that comes to you from billions of light years away. You have just heard two black holes spiraling inward, colliding and merging into a single, even larger black hole. Gravitational waves are a new way to observe the universe. They are a new kind of message, a story told not in light, but in the vibrations of space-time itself. They allow us to listen to the universe's most cataclysmic events: the merging of black holes, the collision of neutron stars, and the brilliant, violent explosions of supernovae. And in listening to these stories, we are learning things we never could have known from light alone. We are learning about the population of black holes in the universe, about the birth of heavy elements like gold and platinum, and about the very nature of space-time itself. So let's take a moment to absorb this. We are in a universe that is mostly unseen and unknown, a universe sculpted by the gravitational pull of dark matter and pushed apart by the mysterious force of dark energy. A universe that holds within it the silent, powerful mysteries of black holes, the beautiful monuments to the death of stars, and a universe that, through the gentle ripples of gravitational waves, is finally beginning to tell us its most dramatic and secret stories. It is a humbling and inspiring thought, a reminder that the universe's great truths are not always shouted, but often whispered in the silent, invisible spaces between things. And as we continue to listen and to watch, we find ourselves a little closer to the heart of its mystery. Let's turn our gaze to a different kind of story, one of creation and birth. We've spoken of the universe's grand beginnings, its unseen forces, and its great mysteries. But how did the beautiful shimmering things that we can actually see come to be? How did the cosmos go from a simple soup of hydrogen and helium to the complex tapestry of stars and galaxies that fills our night sky? We'll begin tonight with the life cycle of a single star, a story of fiery birth, brilliant life, and spectacular death, a process that is at the heart of our own existence. Imagine a vast, dark, cold cloud of gas and dust floating silently in the emptiness of space. This is a nebula, a stellar nursery, a beautiful cosmic womb where new stars are born. These nebulae are the remnants of older stars that lived and died long ago, their material spread across the cosmos like the gentle scattering of seeds. In this great dark cloud, the particles of gas and dust are not perfectly uniform. There are slight variations, tiny clumps, where the matter is just a little bit denser. And here, the gentle, relentless hand of gravity begins its work. Over millions of years, gravity pulls these denser clumps together like a slow, patient artist shaping a ball of clay. As the clump grows, it pulls in more and more material, becoming larger and denser. The gravitational pressure at its center increases, and as it does, the temperature begins to rise. The clump, now a protostar, begins to glow with a faint warm light, a new life just beginning to stir. The protostar is not yet a true star. It's a work in progress, a star in its infancy, still gathering its strength and its material. It is in this stage that it becomes surrounded by a rotating disk of leftover gas and dust, a swirling cosmic kitchen where the ingredients for a new planetary system are being mixed. The protostar continues to collapse and heat up the pressure at its core, growing to unimaginable levels. the heat and pressure become so intense that a new kind of alchemy takes place. The hydrogen atoms at the core begin to collide and fuse together, creating helium and releasing an incredible amount of energy in the form of light and heat. This is the moment of a star's birth. The outward pressure from this nuclear fusion is now strong enough to counteract the inward pull of gravity, and the star settles into a state of equilibrium, a stable, luminous being. Our own sun, along with countless other stars, was born in this very manner from a nebula roughly 4.6 billion years ago. The new star shines brightly, a brilliant beacon in the darkness, a cosmic engine of creation, converting hydrogen into helium in its core for billions of years. But a star's life, like all things, is finite. For a star like our sun, its life is long and steady. But for more massive stars, their lives are more brief and dramatic. When a star begins to run out of its primary fuel, hydrogen, its story takes a new turn. The core begins to collapse again, and the star expands, becoming a red giant, or, for even more massive stars, a red supergiant. As the star's core collapses, the temperature and pressure increase once more, allowing the star to begin fusing heavier elements: carbon, oxygen, neon silicon, and even iron. In a massive star, this process of creation continues in concentric shells, like the layers of an onion, with heavier elements being forged at the core. But the process of fusion stops at iron. Fusing iron requires more energy than it produces, and so, when a massive star's core becomes a solid ball of iron, the game is over. The core collapses in a fraction of a second, and the outward pressure from this collapse creates a massive shock wave that blows the outer layers of the star away in a brilliant, violent explosion known as a supernova. This supernova is not just a death, it is a profound act of creation. In the brief, intense flash of the explosion, the star forges all the elements heavier than iron, scattering them across the cosmos. The gold in your jewelry, the silver in a coin, the iron in your blood, all of it was forged in the fiery heart of a supernova long ago. The star dies, but its legacy lives on, enriching the cosmic environment with the heavy elements necessary for the formation of new stars, new planets, and new life. The death of one star is the birth of another, a beautiful eternal cycle of cosmic recycling. Let's allow our minds to float gently away from the brilliant flash of the supernova and turn to the next part of this creation story, the formation of planets. We mentioned earlier the swirling disk of leftover gas and dust that surrounds a newborn star. This is the protoplanetary disk, and it is the birthplace of planets, moons, and other celestial bodies. Imagine this disk as a vast rotating kitchen with all the ingredients for a new solar system swirling within it. In this kitchen, a new kind of creative process begins. Tiny particles of dust and gas begin to collide and stick together, a process known as accretion. Initially, these are just microscopic grains like the motes of dust you see dancing in a sunbeam. But over time, they gather together into larger and larger clumps, forming objects the size of pebbles, then rocks, then asteroids, and finally small planets known as planetesimals. As these planetesimals grow, their gravitational pull increases, allowing them to sweep up even more material from the surrounding disk. It's a runaway process, a snowball rolling down a hill, getting bigger and bigger with every turn. The planets that form closer to the star in the warmer inner regions of the disk are made of rock and metal, as the heat from the star would have vaporized the lighter gases and ices. This is how planets like Earth, Mars, Venus, and Mercury were formed. Farther out from the star, beyond a cosmic boundary known as the snowline, the conditions were much cooler. Here, the gases and ices were able to freeze, providing a much richer supply of material for the forming planets. These planets grew to immense sizes, gathering vast amounts of hydrogen and helium gas from the disk, becoming the gas giants we see today: Jupiter, Saturn, Uranus, and Neptune. After a few million years, the young star ignites its powerful solar winds, blowing away the remaining gas and dust from the disk, halting the growth of the planets. The solar system is now a finished masterpiece, a beautiful family of planets, each with its own unique personality orbiting a single luminous star. And this leads us to another fascinating idea, that our solar system is not unique. The discovery of planets outside our own solar system, or exoplanets, has revolutionized our understanding of the cosmos. Before the 1990s, we had no direct evidence that other stars had planets. Our view of the cosmos was centered on our own solar system, a singular, unique creation. But since then, we've discovered thousands of exoplanets, and we've learned that the formation of planets is a common, widespread process. Exoplanets come in a wide array of sizes and compositions, from gas giants larger than Jupiter to rocky planets that could be similar to Earth. This diversity challenges our previous assumptions about planetary formation and the conditions necessary for life. We are learning that our solar system is just one of many, each with its own unique characteristics. And with every new discovery, we are reminded that the universe is far more populated and far more mysterious than we ever could have imagined. So let's take a final moment to rest in this story of creation. We've seen how stars are born from vast, dark nebulae, live out their lives in a brilliant blaze of fusion, and die in a spectacular supernova, a final generous act of creation. We've seen how planets are born from the leftover dust and gas of a star's birth, each one a unique world in its own right. And we've learned that this process of creation is not unique to our own star, but is a common, widespread event throughout the cosmos. It's a thought that is both humbling and deeply inspiring, a quiet reminder that we are all in a very real way made of stars. Tonight, let's gently guide our thoughts toward one of humanity's most profound and persistent questions. Are we alone? We've seen how stars and planets form, and we've learned that our own solar system is just one of many. Now let's explore the vast, quiet expanse of the cosmos with a new purpose to find a sign of life, a whisper of another story in the deep darkness. This is the realm of astrobiology, a field that combines astronomy, biology, and chemistry to search for life beyond our home. Our search begins with a simple yet crucial idea: the habitable zone, often lovingly called the Goldilocks zone. Imagine a star like our sun shining its warm light into the surrounding space. If a planet is too close, it's too hot, and any water would boil away. If it's too far away, it's too cold, and any water would freeze solid. But in a certain orbit, a specific distance from the star, conditions are just right for liquid water to exist on the planet's surface. This is the habitable zone. Water is the key ingredient for all life as we know it, a universal solvent that allows the complex chemistry of life to unfold. Finding a planet in this zone is the first gentle step in our search. But our understanding of what a habitable environment truly means has been radically expanded by some of the most surprising inhabitants of our own planet, the extremophiles. These are remarkable organisms that thrive in conditions that would be lethal to most other life forms. They can be found in the superheated water of deep-sea hydrothermal vents, in the frozen airless valleys of Antarctica, in highly acidic springs, and even in the toxic waste of nuclear reactors. These creatures, these quiet survivors, challenge our narrow Earth-centric view of what life requires. They have taught us that life is incredibly resilient, adaptable, and inventive. The extremophiles give us hope. If life can thrive in the absence of sunlight, in crushing pressure, in extreme heat or cold, then the universe's potential for hosting life is far greater than we once imagined. The icy moons of Jupiter and Saturn, like Europa and Enceladus, are now considered prime candidates in our search. Europa is believed to have a vast subsurface ocean of liquid water kept warm by the tidal forces of Jupiter. Enceladus, a small icy moon of Saturn, has geysers that spew water vapor into space, hinting at a liquid ocean beneath its frozen crust. These are not in our sun's Goldilocks zone, but the internal heat of their parent planets might create their own secret habitable zones. These quiet hidden oceans could be teeming with life, a different kind of life, a story of survival in the deep dark. But our search for life is not just a search for places to live. It's a search for biosignatures, the chemical whispers that life leaves behind. When we look at the atmospheres of distant exoplanets, we can use sophisticated telescopes to analyze the light that passes through them. By breaking down that light into a spectrum, we can identify the chemical fingerprints of the gases in the atmosphere. The presence of certain molecules in unusual abundances like methane or oxygen could be a sign that biological processes are at work. The next generation of telescopes, like the James Webb Space Telescope, is designed to do just that, to analyze the faint light from distant worlds and listen for the telltale signs of life. The search for extraterrestrial life brings us to two of the most beautiful and poignant ideas in astrobiology, the Drake equation and the Fermi paradox. The Drake equation, formulated by the astrophysicist Frank Drake in the 1960s, is not meant to give us a definitive number. Instead, it is a framework, a series of questions that we must ask ourselves in order to even begin to think about the possibility of intelligent, communicative life in our galaxy. It asks us to consider the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction of those planets where life actually arises, the fraction of that life that becomes intelligent, the fraction of intelligent life that develops a technology to communicate, and the lifespan of such a civilization. It is a beautiful way to frame a question, a gentle guide for our curiosity. And yet, despite the vast number of stars and planets we are now discovering, the universe seems to be profoundly silent. This brings us to the Fermi paradox, named after the physicist Enrico Fermi, who, while having lunch one day, supposedly asked a simple but profound question: where is everybody? If the universe is so vast, and if the probability of life is so high, why have we not yet found any definitive evidence of intelligent extraterrestrial life? It is a question that haunts our search, a silent, echoing mystery. There are many possible answers to the Fermi paradox, each one a story in itself. Perhaps civilizations are rare. Perhaps they don't last very long. Perhaps they choose to remain silent, listening, rather than broadcasting. Or perhaps the most unsettling thought of all is that we are simply too early, that we are the first, a single candle in a great dark hall, waiting for the others to light their own. So let's allow ourselves to rest in this question. The universe is a vast and mysterious place, filled with silent planets and swirling nebulae, and we are just beginning our search for companionship. We have a framework for our questions, the Drake equation, and a silent mystery to guide us, the Fermi paradox. And in the quiet spaces between the questions, in the silent hum of the cosmos, we can feel a deep sense of connection, a feeling that we are part of something so grand, so beautiful, so impossibly large, that even if we are alone, we are not truly lonely. We are the universe's way of asking a question of itself, and in our searching, in our wondering, we are creating a story that is as vast and as beautiful as the cosmos itself. Let's turn our gaze inward now, from the vastness of the cosmos to the intricate world of our own origins. We've spoken of the universe's creation, the birth of stars and planets, and the quiet search for life beyond our home. But how did life begin here on our small blue world? This is a profound mystery, a story that is etched into the very rocks and oceans of our planet. Tonight, we'll gently explore the story of life's beginnings, from a simple primordial soup to the bustling life we see today. Imagine Earth billions of years ago. The planet is a chaotic, turbulent place with a young, volatile atmosphere, frequent volcanic eruptions, and a constant barrage of energy from lightning and ultraviolet radiation. The oceans, warmed by the planet's internal heat, were a different kind of broth, rich with the basic building blocks of life, organic molecules. This is the essence of the primordial soup theory, a beautiful, elegant idea that suggests life began in these early oceans, a natural laboratory where the right ingredients under the right conditions could react and interact, gradually forming more complex compounds. In this ancient ocean, simple molecules might have been brought together by chance, energized by the constant crackle of lightning. Imagine a quiet, warm pool where the chemicals are slowly, patiently turning into something more. Amino acids, the building blocks of proteins, might have formed here, a crucial first step on the long road to life. Over millions of years, these amino acids could have assembled into chains, forming the first proteins, the first complex molecules that could store information and replicate themselves. It was a slow, deliberate dance of chemistry, a gradual journey from non-living matter to the first primitive forms of life. The famous Miller-Urey experiment in the 1950s showed that organic molecules could indeed form in conditions thought to resemble early Earth. Giving significant credence to this soup theory, a gentle reminder that life's origins might have been a simple natural outcome of a complex world. But there is another story of life's beginnings, a quieter, more dramatic one found deep beneath the ocean's surface. Imagine the crushing pressure and the complete darkness of the deep ocean floor. Here, far from the sun's energy, are the hydrothermal vents. These underwater fissures release superheated mineral-rich water from beneath the Earth's crust, creating a unique, vibrant ecosystem. The conditions here are harsh, but they are also stable, providing a continuous source of heat and chemical energy. This is a powerful idea that life may not have started with the sun, but with the Earth's own internal heat, in a place protected from the chaos and turmoil of the surface. At these vents, a different kind of life has taken hold. Organisms here perform chemosynthesis, converting the chemicals from the vents into energy completely independent of the sun. These living beings, these deep-sea survivors, are a living testament to the possibility of life thriving in extreme conditions. Their existence on our own planet provides a powerful clue in our search for life elsewhere, reminding us that life can be far more diverse and adaptable than we ever imagined. The idea that life could have emerged in a place so different from our own, a place of extreme pressure and absolute darkness, is a beautiful, humbling thought, and it opens up a new chapter in our story of life's origins. And what if the ingredients for life came from even farther away? What if the seeds of life were not unique to Earth, but were scattered throughout the cosmos? This is the core idea of panspermia, a theory that suggests that the basic building blocks of life could be delivered to our planet by cosmic visitors, meteorites. These celestial travelers' remnants from the early solar system have been found to contain organic molecules including amino acids, the very same building blocks we spoke of earlier. These ancient time capsules, traveling through the cold, dark vacuum of space, could have seeded our young planet with the crucial ingredients for life, providing a cosmic spark that set off the chain of events that led to us. It's a profound thought that our origins might not just be of this world, but of the universe itself. Now let's fast forward a few billion years. The first simple life forms have emerged and have taken hold, but their journey is not a straight line. It is a story of great change, of sudden violent events that reshape the course of life on Earth. These are the mass extinction events. Imagine a great cosmic storm that sweeps across the planet, erasing up to 90% of all life. These events, whether caused by a massive asteroid, impact a series of catastrophic volcanic eruptions, or sudden dramatic shift in climate, are not an end, but a pivotal turning point. After each extinction, the planet is left with a blank slate. The dominant species are gone, and a vast number of ecological niches are left vacant. This creates a powerful opportunity for new forms of life to emerge. The survivors, those organisms that were resilient enough to endure the storm, are now free to diversify and flourish, to fill the roles left vacant by the extinct species. This phenomenon, known as adaptive radiation, is like a great burst of evolutionary creativity, a quiet, profound rebirth. The most famous example, of course, is the extinction event that wiped out the dinosaurs 66 million years ago. With the dinosaurs gone, the small, unassuming mammals were able to diversify dramatically, eventually leading to our own ancestors. And this brings us to the very heart of the story of life evolution. It is a compelling framework for understanding the incredible diversity of life we see on Earth today. The theory posits that all living organisms share a common ancestor and that over vast periods, species have changed and diversified through a process called natural selection. This process is a gentle but relentless engine of change. Imagine a population of organisms with a variety of different traits. The environment changes. A new predator appears. The climate becomes warmer. A new food source becomes available. Some of the organisms, by pure chance, have traits that are better suited to this new environment. They are more likely to survive to reproduce and to pass those advantageous traits on to their offspring. Over countless generations, these advantageous traits become more and more common in the population, leading to gradual adaptations and the emergence of new species. This is not a conscious process. It is a quiet, ongoing dance between an organism and its environment. The fossil record, a beautiful silent story told in stone, provides crucial evidence for this process. By examining the skeletons of ancient creatures, we can trace a historical progression of life, forms a gradual transformation over millions of years, and modern genetic studies which allow us to analyze the DNA sequences of different organisms reinforce this idea of a shared ancestry, highlighting the deep, intricate connections between all living things. And finally, let's turn our attention to the remarkable adaptations that make us uniquely human. One of the most important is our brain, a marvel of complexity that allows for abstract reasoning language and creativity. Another is our ability to walk upright bipedalism, which freed our hands for tool use and manipulation, a crucial step in our development. And perhaps most importantly, our capacity for social cooperation, which allowed us to build intricate societies, share knowledge, and care for one another. These adaptations, these quiet shifts in our biology and behavior, set us on a path that would lead us to where we are today, looking up at the stars and wondering about our place in the universe. So let yourself rest in this story of life. We've seen how it might have begun in a primordial soup, how it was forged in the heat of deep-sea vents, how it was reset by great cosmic storms, and how it evolved into a beautiful, diverse tapestry through the gentle, ongoing process of natural selection. It is a story of resilience and adaptation, a story that reminds us that we are not separate from this great epic, but an intimate, vital part of it. We are a part of a beautiful unfolding tale, a tale that began in the simple waters of an ancient ocean and has led to the quiet comfort of your own room. Let's now gently shift our focus from the broad sweep of biological evolution to the more intimate and intricate world of the mind. We have explored the birth of the universe and the emergence of life from non-living matter. But what happened next? How did a complex web of neurons and synapses give rise to the rich inner life we all experience? Tonight, we'll tiptoe into the profound and elusive territory of consciousness and cognition, a journey into the heart of what it means to be aware. The very word, consciousness, is a gentle echo in the quiet halls of science, a concept that is both deeply familiar and utterly mysterious. From a scientific standpoint, consciousness is often defined as our awareness of self, our surroundings, and our thoughts. It's the feeling of being, the subjective experience that colors our every moment. And yet, despite significant advancements in neuroscience and psychology, we still grapple with a fundamental question. How does the physical activity of the brain, a collection of electrical impulses and chemical reactions, give rise to this rich, subjective, and personal experience? This is what philosopher David Chalmers has called the hard problem of consciousness, and it is a gentle reminder that some of the most profound mysteries are not out in the cosmos, but right here within us. Our journey to understand consciousness often begins by looking at the incredible complexity of the human brain. Neuroscientists use a variety of sophisticated tools to peer into this intricate universe, mapping its structures and observing its activity. Neuroimaging techniques, like functional MRI, allow us to see which parts of the brain become active during different tasks, from solving a puzzle to simply resting. It's like watching a bustling city from above, observing which neighborhoods light up as people go about their day. This research has helped us to map the neural correlates of consciousness, identifying specific regions and networks that seem to be involved in our conscious experience. But a map is not the territory itself. We can see that the lights are on, but we still don't know what it feels like to be inside one of those houses. The leap from neural activity to the subjective feeling of awareness remains a mystery. One powerful approach to understanding consciousness is to consider it from a different perspective, not as a singular thing, but as a spectrum. If we are conscious, are other animals also conscious? Do they also experience a rich inner life? This is the realm of animal cognition, and the discoveries here are both humbling and inspiring. For a long time, humans have viewed intelligence as a unique human trait, a quality that separates us from the rest of the animal kingdom. But research has demonstrated that many species exhibit complex behaviors and mental processes that challenge this notion. Imagine a clever crow, a small black bird that can use tools. It doesn't just pick up a stick. It can bend a piece of wire into a hook to extract a piece of food from a small jar. This is not a simple instinctual behavior. It is a sign of foresight, of problem solving, of an understanding of cause and effect. Or consider the intricate communication systems of dolphins, their complex clicks and whistles, conveying information, coordinating hunting strategies, and navigating their environment. These are not just sounds. They are a sign of a sophisticated social intelligence, of a rich inner world of relationships and cooperation. Even more profoundly, some animals like elephants and dogs exhibit behaviors that suggest a capacity for empathy and compassion. The quiet, dignified mourning of an elephant for a lost loved one, the comforting presence of a dog when its owner is sad. These are not just simple reactions. They are a reflection of a deeper emotional intelligence, a capacity for feeling and connection that we once thought was unique to us. These discoveries remind us that intelligence is not a singular monolithic thing. It is a spectrum, a mosaic of different skills and strategies that have evolved over millions of years to help each species thrive in its unique environment. The intelligence of a crow is not the intelligence of a dolphin, and neither is the intelligence of a human. They are all different facets of a single beautiful gem, a testament to the endless creativity of evolution. So where does this leave us in our understanding of consciousness? The study of animal cognition doesn't give us a definitive answer to the hard problem, but it does give us a new perspective. It reminds us that our own consciousness may not be a singular, isolated phenomenon, but a part of a larger, more beautiful story. It encourages us to approach the world with a sense of wonder, to see not just animals, but conscious beings, each with its own unique story, each with its own unique way of experiencing the world. The journey into the mind is a gentle one, full of questions and few definitive answers. We can use advanced technology to peer into the brain, but we are still left with the profound, unyielding mystery of how a collection of physical parts can give rise to the feeling of being. We can observe the complex behaviors of animals, but we are still left with the question of what it feels like to be a crow, to be a dolphin, to be an elephant. These are the mysteries that remain, the quiet spaces where science gives way to philosophy, where knowledge gives way to wonder. Perhaps the answers we seek are not meant to be found in a single equation or a single experiment. Perhaps the journey itself, the quiet contemplation of these profound questions, is the answer. Perhaps the purpose of our consciousness is not to solve the mystery of itself, but to simply wonder at its own existence, to marvel at the beautiful, intricate, and deeply personal experience of being alive. So let yourself rest in this thought that the universe has not only created stars and galaxies, but has also created a mind that can contemplate them, a mind that can ask these very questions. And in that, there is a profound, quiet peace. Let's turn our gaze to a different kind of story tonight, one that reminds us that humanity's search for meaning is not a solitary one. We have explored the deep questions of physics and biology, of the universe's beginning, and the mind's complexity. But all of these questions, all of our answers are shaped by the stories we tell, the beliefs we hold, and the cultures we build. Tonight, let's drift through the quiet, profound intersection of science and culture, a place where the stars are not just burning balls of gas, but also mirrors of our own hopes and fears. From the very beginning, humans have looked up at the night sky with a sense of wonder and curiosity. Before we had telescopes or scientific theories, we had myths and legends. The ancient civilizations of the Mayans, the Egyptians, and the Greeks meticulously observed the movements of the sun, moon, and stars, not just as a matter of scientific inquiry, but as a way of life. The constellations were not just random clusters of stars. They were the figures of gods and goddesses, the heroes of epic tales, the silent narrators of our own stories. The movement of the planets was not just an orbital dance. It was a divine clock, a guide for agriculture, for religious festivals, for the very rhythm of our lives. These ancient cultures saw themselves as an intimate part of a greater interconnected cosmos, a universe that was alive and full of meaning. The shift from myth to science was a slow, quiet, and profound one. The advent of powerful telescopes in the 17th century, the meticulous observations of Galileo, the brilliant mathematical formulations of Kepler and Newton, all of this began to change our story. The cosmos was no longer a realm of divine beings. It was a subject of rigorous empirical study. This was a challenging transition, one that upended long-held beliefs and asked us to find new stories, new ways of understanding our place in the universe. But in the end, it was a beautiful transition, one that gave us a new kind of wonder, a wonder that comes not from a mystery that is hidden, but from a mystery that is revealed one equation at a time. And this new scientific understanding of the cosmos, in turn, began to shape our culture in new ways. The vast star-filled images from the Hubble Space Telescope, the meticulous data from the Mars rovers, the quiet thrill of a new discovery about a distant galaxy, all of this has become a part of our shared cultural narrative. It has seeped into our art, our literature, our film, our music. Science fiction, a genre that once seemed purely fantastical, has become a mirror of our own ambitions and anxieties. The journey of the Starship Enterprise, the quiet, lonely contemplation of a lone astronaut on Mars, the sense of awe and terror at the discovery of a new alien world. These are the new myths of our time, the stories that help us to process our place in this vast, evolving universe. But the influence of culture on science is a two-way street. Scientific inquiry is not a purely objective, dispassionate process. It is a deeply human endeavor, and it is shaped by the cultures in which it is born. Different cultures may prioritize different questions, different methodologies, and different ways of interpreting data. The quiet, profound knowledge of indigenous cultures, for example, about the natural world, about the movements of the sun and the moon, about the changing of the seasons, is a form of scientific knowledge that has been passed down for generations. And by respectfully incorporating these diverse perspectives, science can become more robust, more creative, more deeply connected to the world it seeks to understand. And then there is the beautiful, powerful interplay between the public and the scientific community. Space exploration is not just the domain of a few scientists and engineers. It is a shared journey, and it is fueled by public interest and enthusiasm. When the public is engaged, when they are captivated by the images from the James Webb Space Telescope or the quiet, determined journey of a Mars rover, it often translates into increased funding, into new missions, into a greater sense of shared purpose. The public's fascination with the cosmos is the gentle wind in our sails, pushing our scientific ambitions forward. And perhaps most importantly, space exploration is a testament to the power of international collaboration. The International Space Station, a marvel of engineering and human cooperation, is not just a scientific laboratory in orbit. It is a symbol, a quiet, powerful symbol of what we can achieve when we set aside our differences and work together toward a common goal. The study of the cosmos, a place that belongs to no one and everyone, has a unique ability to bring us together to remind us that we are all in the end inhabitants of a single small planet, and that our greatest challenge and our greatest opportunity is to learn how to live together both here and perhaps one day out there. So let's take a moment to rest in this thought that the story of our universe is not just a story of physics and chemistry, but a story of our own humanity. It is a story of myth and legend, of scientific discovery and artistic expression, of a shared journey toward understanding. And in this story, the stars are not just burning balls of gas. They are mirrors of our own hopes and fears, silent witnesses to our quest to find meaning in a universe that is both vast and beautiful and deeply, profoundly ours. Let's look ahead now to the future, to the next chapter of our story. We've come so far from contemplating the birth of the cosmos to reflecting on the gentle rise of consciousness. But what's next? What new frontiers beckon us tonight? We'll drift into the bold and ambitious plans for our future. In space, the technologies that will take us there, and the profound ethical questions that these journeys will force us to ask. The first quiet whisper of the future is the next generation of telescopes. We have already seen the breathtaking, humbling images from the James Webb Space Telescope, which has allowed us to peer deeper into space and further back in time than ever before. But these are just the first few notes of a brand new symphony. Future instruments, both in space and on the ground, will be even more powerful, more precise, and more sensitive. They will allow us to not only find exoplanets, but to analyze their atmospheres in unprecedented detail, searching for the telltale signs of life, the chemical biosignatures that could tell us we are not alone. They will allow us to map the invisible scaffolding of dark matter with a new kind of clarity, and to listen to the distant gravitational ripples of the universe's most violent events. These new telescopes are not just tools. They are our new eyes and ears, extending our senses into the deep cosmic night. But our future in space is not just about observing. It is about doing. It is about a return to the moon, a place that we have not visited in more than half a century. NASA's Artemis program, a name that evokes the Greek goddess of the moon, is a new ambitious plan to land the next astronauts on the lunar surface, including the first woman and the next man. This is not a simple repetition of the past. The goal of Artemis is not just to plant a flag, but to establish a long-term sustainable presence on the moon, to learn how to live and work in an off-world environment. The moon will be our proving ground, our cosmic boot camp, where we will test the technologies and the human endurance that will be necessary for a far more ambitious journey, the journey to Mars. And Mars, the quiet red planet, is the next great destination. The exploration of Mars is not just a dream, it is an ongoing reality. NASA's Perseverance rover is already on the Martian surface, searching for signs of ancient life and collecting rock and soil samples that will one day be returned to Earth for study. These missions are not just about finding life, they are about understanding our solar system's history, the processes that led to the development of planets, and the limits of where life can exist. The journey to Mars will be a long and challenging one, a profound test of our technology, our resolve, and our resilience. It is a journey that will force us to ask a question that we have never had to ask before. What does it mean to be a human on another world? And who will take us on this journey? Historically, space exploration was the sole domain of governmental agencies. But in recent years, a new and exciting force has emerged: private companies. Companies like SpaceX and Blue Origin are revolutionizing space travel, developing rockets that can be reused, and spacecraft that can carry both cargo and astronauts to the International Space Station. This new era of commercial space exploration is not just about making space more accessible. It is about making it more innovative, more agile, and more sustainable. This new collaboration between public and private enterprises is a powerful synergistic force, one that is accelerating our journey into the cosmos and opening up new possibilities that we are only just beginning to imagine. But as we look to the future, as we plan our journeys to the Moon and Mars, we must also consider the profound ethical implications of our actions. The first and most important of these is planetary protection. When we send a rover or a human to another world, we risk contaminating that pristine environment with organisms from Earth. This is not a small concern. What if we were to introduce our own microbes to a place like Europa or Enceladus, and in doing so, destroy a fragile alien ecosystem before we even had a chance to discover it? Or what if in our search for life, we were to bring back a new unknown organism that could pose a risk to life on Earth? These are not questions that can be answered by technology alone. They are moral questions, and they demand a new kind of humility and a new kind of responsibility. And then there is the question of colonization. As we look to the stars, we must confront our own history here on Earth. Our history is full of stories of colonization, of one group of people arriving on a new land and exploiting its resources, its people, and its ecosystems. As we plan our journeys to other worlds, we must ask ourselves, what right do we have to alter or inhabit these worlds? Who owns the resources on the Moon or on an asteroid? Should there be a set of laws, a kind of cosmic treaty that governs our actions in space, ensuring that our presence there is ethical, equitable, and sustainable? These are not easy questions. They are a gentle but firm reminder that our journey into the cosmos is not just an outward journey of discovery, but an inward journey of self-reflection. And finally, we must consider the effects of these long-duration space flights on our own bodies and minds. The human body is a marvel of evolution, perfectly adapted for life here on Earth. But a long journey to Mars will take us far outside of our comfortable cosmic cocoon. In the microgravity environment of space, our muscles atrophy, our bones lose density, and our vision can be affected. On a long journey, the mind also faces new challenges. The isolation, the confinement, the immense distance from our home and our loved ones. These are profound psychological burdens, but these challenges also present a new kind of opportunity. By studying the effects of spaceflight on the human body, we are learning new things about human resilience, about how to care for our bodies and our minds in the most extreme conditions. And by looking back at our own planet, from the quiet, profound perspective of space, we are learning a new kind of humility, a new kind of responsibility, a new kind of reverence for the small blue world that is our only home. Let's bring our gentle journey to a close, a final quiet moment of reflection on all that we have explored together. We began with the vast, humbling story of the cosmos and have now arrived at the intricate and profound story of ourselves. Tonight, let's rest in the quiet, beautiful spaces where the questions remain unanswered, where our story is still being written, and where our very existence is a testament to the endless wonder of the universe. We've spoken of dark matter and dark energy, the unseen forces that make up the vast majority of our universe. We have no definitive answers to what they are, and our current understanding of physics breaks down when we try to peer into their nature. And this is perhaps one of the most beautiful lessons of all. It reminds us that our knowledge is not a finished book, but a continuous story, a work in progress. It is a quiet invitation to remain humble, to be comfortable with the unknown, and to find a profound sense of awe in the fact that what we don't know is far more magnificent than what we do. The existence of these cosmic enigmas means that the universe is far from being a solved puzzle. It is a mystery that continues to beckon us forward, a silent, powerful force that will drive our scientific exploration for generations to come. Imagine for a moment that all of our knowledge of the universe is like a single small island in a vast, dark ocean. We have mapped every rock, every tree, every tiny stream on our island. We know its every detail, its every secret. But the ocean that surrounds it, the deep, dark, silent ocean, is a mystery. We can feel its presence in the tides that lap our shores, in the quiet hum of its currents. But we cannot see it. We cannot touch it. We cannot know it. This is our situation with dark matter and dark energy. We can feel their presence. We can see their effects on the visible world, but their true nature remains elusive. And in that quiet uncertainty, there is a kind of beautiful poetry, a profound sense of wonder that can fill the soul. And so, as we end our gentle journey, let's hold on to this feeling of wonder. The universe is a vast, beautiful, and deeply mysterious place. It is filled with unseen forces, silent cosmic events, and profound questions that we may never fully answer. But in this uncertainty, there is a kind of peace. We are not separate from this story. We are an intimate, vital part of it. The starlight that has traveled for billions of years to reach your eyes tonight is a direct link to the universe's past. The air you breathe, the ground you stand on, the very thoughts in your head, all of it is a beautiful, intricate part of a single, continuous cosmic epic. The quest for answers will continue. The story will unfold. Our curiosity will light the way forward. But for tonight, let's simply rest knowing that we are a part of a beautiful, endless story. A story that is as vast as the cosmos and as intimate as a single breath. Good night. Our quiet reflection on the mysteries of the universe and our place within it would be incomplete without considering the profound influence of our own minds. We've spoken of the intricate dance of atoms and the grand ballet of galaxies, but at the heart of our story lies the mind that can contemplate such things. We have explored the deep mystery of our own existence, from the chaotic ancient oceans to the gentle rise of consciousness. We still don't know exactly how life began, or how a collection of physical parts in our brain gives rise to the subjective personal feeling of being. These are the mysteries that are not out in the stars, but right here within us. Imagine your consciousness as a quiet, luminous room within a great dark house. The house is your brain, a complex, intricate structure of countless rooms and hallways. We can use a flashlight to explore some of the rooms, to see the furniture, to understand how the electricity works. But we still don't know why in this one particular room there is a light, a feeling of being that illuminates all the others. This is the hard problem of consciousness, and it is a gentle reminder that some of the most profound mysteries are not out in the cosmos, but right here within us. The existence of our own inner world is a profound enigma, a puzzle that challenges our every notion of what is real. And in this challenge, there is a kind of beautiful poetry, a sense of wonder that can fill the soul. The journey into our own minds is a journey into the universe itself. Our thoughts, our feelings, our memories, all of it is a reflection of the intricate dance of matter and energy that began with the Big Bang. The iron in our blood, the calcium in our bones, all of it was forged in the fiery heart of a star that lived and died billions of years ago. Our consciousness, our ability to wonder, to ask these very questions, is perhaps the universe's most profound and beautiful achievement. It is a testament to the fact that from the silent, inert dust of a long-dead star, a mind has emerged, a mind that can contemplate its own origins. And this brings us to the core of our journey, the role of human curiosity. From the earliest civilizations that looked up at the night sky and saw gods and legends, to the modern astronomers who peer into the farthest reaches of the universe with powerful telescopes, our innate desire to know, to understand, has been the driving force behind our exploration. Curiosity is not just a scientific tool. It is a fundamental part of what it means to be human. It is the engine of our creativity, the wellspring of our innovation, and the quiet, persistent voice that pushes us to ask, what if and why? It is the force that has allowed us to discover that we are made of stardust, and it is the force that will one day perhaps allow us to find a new home in the stars. Imagine a small child looking up at the night sky for the very first time. They don't know the names of the constellations, or the distance to the moon, or the age of the universe. All they know is that it is vast and beautiful and mysterious. And they ask a simple question: what is that? In that simple question lies the entire history of human exploration, the entire story of our scientific journey. It is the beginning of everything. And it is a reminder that our curiosity is not a learned behavior. It is a fundamental part of our nature, a quiet, powerful force that connects us to the cosmos. It is a shared heritage, a common thread that runs through every human culture, every scientific discovery, every story we've ever told. And this curiosity is not just a force for discovery. It is also a force for connection. As we've explored the universe together, we've seen how our journey has brought us closer to each other. The International Space Station, a symbol of international collaboration, is a testament to what we can achieve when we set aside our differences and work together. The public's fascination with space exploration, a shared sense of awe and wonder, is a force that can unite us, a gentle reminder that we are all, in the end, inhabitants of a single small planet, and that our greatest challenge and our greatest opportunity is to learn how to live together both here and perhaps one day out there. So as we end our gentle journey, let's hold on to this feeling of wonder. The universe is a vast, beautiful, and deeply mysterious place. It is filled with unseen forces, silent cosmic events, and profound questions that we may never fully answer. But in this uncertainty, there is a kind of peace. We are not separate from this story. We are an intimate, vital part of it. The starlight that has traveled for billions of years to reach your eyes tonight is a direct link to the universe's past. The air you breathe, the ground you stand on, the very thoughts in your head, all of it is a beautiful, intricate part of a single, continuous cosmic epic. The quest for answers will continue. The story will unfold. Our curiosity will light the way forward. But for tonight, let's simply rest, knowing that we are a part of a beautiful, endless story, a story that is as vast as the cosmos and as intimate as a single breath. Good night.